Hello all, good morning. So this is a new the seminar series is being organized by the Kotak IIC AIML Center. So this is a new distinguished seminar series that we are starting from this month, and we hope to have a distinguished seminar every month going forward. And the Kotak Center has been supporting many activities in the areas of AI and ML, and this is one such initiative that we are further starting. So happy to see all of you, and I'll request Sriram to introduce the speaker.
Good morning, everyone. I'm Sriram Ganapati from the Electrical Engineering Department. So today I'm very pleased to introduce one of our close colleagues, friends, as well as the distinguished speaker for this seminar series today is Professor Mitesh Khapra from IIT Madras. So Professor Mitesh is a associate professor in IIT Madras, leading various activities of AI for Bharat. Many of you might have heard this name in terms of building data resources, building models, open source sharing of various resources for both academia and industry. So we are very pleased to have him here. Professor Mitesh has had his PhD and masters from IIT Bombay, as well as he has shared some time in IBM research. And at IIT Madras, along with all the activities, as I mentioned in AI for Bharat, he has been very successful in several research awards, teaching awards, Young Faculty Awards, also Google Faculty Award, and so forth. So we are really happy and honored to have Professor Mitesh give this talk, and also welcome all of you for this KIAC seminar series. Thank you.
Hi all. So first of all, thank you for inviting me here. And today I'm going to talk about our work on Indian language technology. As I was just setting up the slides, I noticed the logo, and I thought I'll say a bit about it. So what's the idea behind the logo? So as you can see, it's an elephant, right? And of course, in Indian culture, elephants have a lot of significance. But it's just not that. So the head of the elephant is our version of A. The trunk is I with the dot on top of it, so AI. And the colors are the colors from the Indian tricolor, so that's the Bharat angle. So that's our way of saying AI for Bharat. I somehow felt like talking about it. I don't know why. I had not planned to. So okay, so now I'll start with the talk. Um, so our mission, okay, at AI for Bharat is very simply stated to make sure that for Indian languages, AI technology is at par with what we assume for English, right? Or what is already out there for English. And we want to do it in the open source by contributing datasets, models, tools, and even applications, right? So even focus on impact on the ground by building applications around the technology that we put out, right? So that's our mission, right? Now, first, before I talk about what we are doing towards this mission, let's question the mission itself, right? Like, why do we want to focus on Indian language technology? So this map that you see on the left hand for you, I don't know, I'm a bit left-right dyslexic, so I always get on this side of the screen, is showing you that if you take any two Indians randomly, right, then the chance that they'll be able to converse with each other is only 36% because they'll not be able to speak each other's language, right? And now we have this not a very imaginative scenario, right? Not a very imaginary scenario where you might have a farmer in Tamil Nadu who wants to have a conversation with a wholesaler in Maharashtra and probably try to sell the paddy which grows in Tamil Nadu. And of course, they don't understand each other's language. So you need this language technology as a bridge. And when I say language technology, I mean speech because they're going to converse, have a voice-based conversation. And then, of course, the translation within, which probably may be text or today even directly, right? And that bridge is needed because of the map that you see that any two randomly picked Indians, there's a very high chance that they will not understand each other's language, right? But of course, today no one wants to talk to humans. They all want to talk to ChatGPT, right? And even in that world, the same holds, right? So all the modern LLMs are predominantly English, right? Of course, that situation is changing. Llama 3.1 is declared to be multilingual, and Hindi is one of the 8 languages that they have prominently showcased and trained and fine-tuned for, and so on. And it's changing, right? But still, we have many languages, and for at least the foreseeable future, we would still need language technology as a bridge, because whatever the power of the LLM that we are seeing in the English world, we want that to be accessible to our population, which may not necessarily be conversant in English, right? So, and the way I would like to put it is that people should not have to make a choice between going digital and staying regional, right? I should be able to stay in my regional language and still access all the power of the modern AI technology which is available on the digital world, right? So that's very important, and that again requires a speech and language technology bridge to be built, right? So that's why this mission, that's why we focus so much on Indian language technology. So if that's the case, right? So where do we stand today? And when I say today, I mean 2021, when we had sort of started, right? And I'm looking at some important foundational areas in language technology: machine translation, language understanding, speech recognition, speech synthesis, all relatable areas. I don't need to tell you why these are important areas and so on. And if you look at the graphs there, right, the orange graphs, orange bars are for popular languages like English and some languages from the West, or even like CJK, Chinese, Japanese, Korean languages. And everywhere you can see that the green bar is much smaller than the orange bar. Don't get too excited about the third plot where the green bar is larger, because there I'm plotting the error, right? So the error for Indian languages is higher than that is for other languages, right? So this is where the situation was, that we are far behind, or at least we were far behind for Indian languages when compared to what is existing or was existing even at that time for English. Of course, English has continued to be an exponential curve even after that with ChatGPT and LLMs and so on, and we were already behind. So how do we catch up, right? So again, before how do we catch up, why were we in this situation, right? So why is it that we do not have or did not have good technology for Indian languages? Any guesses? One word answer? Data, right? So everyone gets that, right? So data or lack of data is the root cause of all sorrows, right? We don't have data or didn't have data enough, right? And that's what it is, right? And here, like, I would like to make a point about democratization of AI, right? So there's a lot of at least marketing and PR around AI has been democratized, right? So, but I would like to understand, or at least make a point, a nuanced point about what democratization means, right? So modern AI has 3 important components. One is the data, right? The next is the algorithms slash implementation slash framework, right? The coding part, if you may, right? And the third is the GPU, compute part, right? So when people say AI has been democratized, they're mainly talking about the middle piece, where the algorithms slash platforms have been democratized, right? But what do I do with it? What do I do with an empty gun, right? I need the bullets to really make it work, right? So that's where the data part comes in. Without data, what will I do with these algorithms? I cannot really make them work for Indian languages. And the third is, of course, compute, right? Without compute, what do I do? Compute, I do understand, cannot be democratized because it's an entity, you have to purchase it and so on. But data, I think, is something that should be collectively democratized so that everyone can build on top of that, right? And that's been one of the important themes or missions for us at AI for Bharat. So if data is the problem, right, why not just solve it? Right? What does it take to solve the problem? So let's look at what is the big deal here, right? So I look at the case of machine translation. Okay. Now we have 22 languages which are officially mentioned. They're called the scheduled languages. They are constitutionally recognized languages mentioned in the Constitution of India. Of course, we have 1500 languages. We have 100 plus languages which have a speaker base of 1 lakh. But these are the 22 languages which are officially mentioned in the Constitution. So let's focus on that. And now it's like common wisdom, right? That if you want to train a good machine translation system, you need at least 1 million parallels. That's an at least number, right? And you need much more, but at least 1 million is a good starting point. Now, if I have to do this for 22 languages, and if I look at a sentence with just 15 words per sentence, which is also on the lower side, a typical Wikipedia article has 20 to 25 words. A typical newspaper article also has that many words. But let's say it's 15, right? And then your cost is 3 rupees per word for human translation, right? So that amounts to a very large number. Not just the cost is not the only factor here. The amount of time it will require to create this kind of a corpus where you're engaging a large team of human translators, doing the right amount of quality control to make sure that you get very good quality output which can be used to train. It's a tedious task, right? It'll take many years to do that, right? So that's the challenge, and it's not just machine translation. If you look at speech recognition, right? Now, for English, one of the most popular data sets which is used for training speech translation, speech recognition models is something known as Libri Speech, which has 960 hours of training data, right? So if you take that as the ballpark, that 1,000 hours is a good number to aim for. Again, 22 languages, 1,000 hours, collecting data from the field, transcribing it, 2 to 3 levels of transcription, maker, checker, super checker, and so on. It all comes to 15,000. We are painfully realizing that 15,000 is also not enough. It comes to 20, 25,000 actually, right? So it's again a very huge number. And for every technology that you want to build, you'll have to deal with this number, right? So now what do you do, right? And how do you deal with this problem? Both time and the cost, right? So what we went for is very close to the Indian Jugaad system, right? So the recipe that we chose is that there's a lot of data lying on the web for free, right? Can you leverage that data? Of course, that data will be noisy. No one is putting out well translated sentences on the web. No one is putting out well transcribed material on the web, right? But there is something. It's better than nothing, right? So can you leverage that? But of course, that by itself may not be enough. So can you add a layer of clean data on top of that, so that the model is initially trained with some kind of noisy data and then sort of steered better with a layer of clean data on top of that, hopefully of a lesser volume than the numbers that I showed on the previous slide, right? And together, large amounts of noisy data followed by a smaller amount of clean data, free, quick, not free takes time, but takes less time because the volume is less. Maybe this combination may work, and then exploit some of the relatedness of our languages, where Maithili uses the same script as Devanagari. Of the 22 languages, 9 languages use Devanagari script, right? So it's possible that some sort of sharing can happen between them. Some sort of transfer can happen between Marathi and Konkani, very related languages. Hindi, Maithili, another example, Assamese, Bengali, and so on, right? So can we leverage that by building large-scale multilingual models, right? And this is not really a recipe that we have come up with or take credit for. This has been a tried and tested recipe in the big tech, right? So Azure, Meta, Google, all of them have done this for different purposes at different points of time, right? It's just that the focus there was not too much on Indian languages, and we wanted to shift the focus on Indian languages by executing this recipe, right? So given this recipe, it's important to realize that this is very heavy on engineering, right? And what I mean by that, why do I bring this point up, is that the reason a lot of this work happened in the deep tech is because engineering is one of the skills that is very easy to get in deep tech industry, right? And that's what their daily bread and butter is. And this is something not so easy to do in academia, because we sort of always end up working on different setups which are not very large scale and so on, and due to various practical reasons, right? It's not passing a judgment on one or the other, but just stating what the situation is, right? But we took a conscious call on doing something which is heavy on engineering, right? So crawling data at scale. Now, Common Crawl is the only initiative which exists publicly where data is crawled at scale and put out in like every month and so on, right? But of course, their Indian languages get lost in one among 1,000 languages. So you need a specific pipeline for mining Indian data, for crawling Indian data. Why do I say that? Because the problems that you encounter when you zoom in into a specific set of languages are very different when you're looking at a zoomed out view of 1,000 languages or just looking at English-centric world and so on. And I'll give you a very precise example to make my point here, right? So when you look at content in Indian languages on the web, the unfortunate reality is that a lot of it is translated content, right? So someone has written an English page, and then people have used automatic translation means, maybe Google Translate or something, and then just translated and put out the content. Now this is, of course, has problems, right? Not just the translation is effect, but actually errors in the data, right? I mean, people who, native readers, when they look at this data, they sort of start cribbing about it, right? And we had a situation where we were not aware of this, right? We got aware of this when someone looked at our Punjabi data and started tweeting that these guys are putting out junk for Punjabi. And he was right. I mean, we did have a lot of translated data which was going in as authentic Punjabi data, right? So then we realized that we need to build these filters for Indian languages. The pipeline has to focus on filters which are specific to Indian languages. Also, a lot of content which gets put out on the web, because our Unicode standardization and all took a bit of time, and adoption took more time. So a lot of non-standard Unicode content also pops up for Indian languages, which then creates problems in downstream training and all that, right? So all of this has to be done ground up for Indian languages. That's where we build the Setu pipeline to crawl data at scale from the web. Right? Similarly, currently we are working on building something known as Anulek. It's an open secret that most of the deep tech large language models, they not only rely on data from the web, but a lot of data from YouTube also goes in, right? Because the amount of diversity there is very high, right? And again, my example here is that when Chandrayaan was launched, right, in many native Indian languages, people were putting out videos ranging from downright euphoria to very technical descriptions, right? That in Tamil about why Chandrayaan was successful, what was the difference from the previous one, what could have gone wrong, and having some technical sort of explanations around it. So people put out a lot of content in voice and video. I mean, you are all aware of that, right? And so it's an important piece from where you could get a lot of language-specific data. So right now we are building a pipeline which can crawl a lot of content from YouTube given specific queries, and then sort of transcribe it automatically using some of the speech recognition models that we have built using clean data, right? And then sort of iteratively use this for training bigger models or for consuming as training data for large language models, right? So that's another pipeline that we have built. Similarly, the Saman pipeline, which tries to mine parallel sentences from the web and so on. I'll maybe talk a bit more about Saman later. But yeah, so that's the conscious choice we took, that we really have to get data at scale, and we have to go and crawl data from the web, because the human equivalent of that is going to be too expensive and too time consuming. This is only bound by the number of CPUs that I can spawn, right? And that's generally easier than hiring large teams of human annotators and so on, right? Similarly, when we are collecting data in-house, for a country-wide effort where you're going to look at 22 languages, the teams are going to be remote and distributed. So we have close to 400 translators plus transcribers working with us to create data for different languages, right? And I don't expect someone being an Assamese translator from Guwahati to relocate to Chennai and sort of work out of the office or lab there, right? So it's of course going to be remote and distributed. So we need to have tools which can manage this distributed workflow at scale and support all the languages that we care about. So when we started, we couldn't find anything which sort of caters to all the needs that we have. So we invested in building these tools, right? And today I take pride in saying that now there's a very similar effort at AI Singapore, where just as we have 22 languages, they care about 11 languages, which are the languages of the migrant labor that comes into Singapore. And these are all Southeast Asian languages, so Thai, Philippines, Indonesian, and so on. And they are having a very similar effort of data collection, right? And our tools are now being used by them to sort of bootstrap their data collection, right? So it was worth investing in that effort to create something which can then be used in other multilingual regions of the world, right? And then of course we try to optimize everything on GPUs, so make sure that when we are doing inferences, we have built a platform called Dhruva, which ensures that it's low cost and we don't end up burning a lot of money on the GPUs, right? So that's we consciously went this engineering route so that we could replicate some of the things that have been successfully done in the deep tech. So with this recipe, right, so what have we cooked so far? So one of our flagship works is our IndicTrans series of model. And this is the largest collection of parallel data that was released for Indian languages, right? And what we did here is that a lot of content gets published in newspaper articles, right? So when India won the World Cup, I'm sure there was an article in English newspaper, Tamil newspaper, Hindi newspaper, and without really intending to be translations of each other, they will accidentally end up writing sentences which are translations, right? Each paper would mention about the fabulous catch by Surya Kumar Yadav, right? And now just by accident, there are these translations lying on the web. All you have to do is put them all together. You can look at it as a large collection of 1 billion English sentences, a large collection of 100 million Hindi sentences, and somewhere these translations are hiding in that, right? And can you find this needle in the haystack, right? And we were able to do that by leveraging a lot of existing work on nearest neighbor mining and so on, which allows us to do this seemingly very difficult problem of n choose 2 pair comparisons in an approximate way and get out these translation pairs, right? And using that, we were able to train our translation model. But as I said, only noisy data is never enough. its purpose is only to reduce the amount of clean data that you need to put in, right? And so we also invest in creating data in-house with the help of our in-house translators. And now we are close to 2 million training sentences. Our goal is 2.2 million, which is 22 languages into 100,000 sentences per language. And we're very close to meeting that goal. The other issue was that because a lot of machine translation work is very West-centric, we did not have good benchmarks which really cater to Indian use cases. Now what I mean by that is that the most popular benchmark which exists for machine translation is the Flores benchmark, right? And the USP of that benchmark is that it supports 200 languages, right? And it's n-way parallel across 200 languages. But the challenge is that all of these data has been English sentences translated to 200 languages, and these English sentences are from Western articles, right? So there would be a sentence on, say, Donald Trump, right? Or there would be a sentence on a monument in Washington and so on, right? So it's not, you wouldn't find a sentence on Bharatnatyam in that. You wouldn't find a sentence on Battle of Panipat in that, right? So we created benchmarks which were taken from Indian sources and cater to like Indian vocabulary, Indian content, Indian culture and so on, so that we can see how these models perform on places where they are going to be used in India. Right? The other issue is that none of the models are what are known as, none of the benchmarks are what are known as source original. The source is always English, so you translate from English to X. So now when I want to evaluate the machine translation system on X to English, I'm doing this sort of a slightly non-optimal thing of taking this sentence as the source and then looking whether the translation was correct or not, right? But actually the data was created in this direction. So you see that there are potential problems with that. So we also invested in creating source original benchmarks where the original sentence was written in Hindi and now we are translating it to English and so on. Right? So some of this work to sort of be able to better benchmark what the technology is reaching towards was also important. And we train a fairly large model, at least at that time, which is multilingual, to ensure that language sharing across languages and so on happens, right? So after doing all this, right, and sort of blabbering about, okay, we did this, that, and so on, have we moved the needle really, right? So that's the question. That's all that matters. And fortunately, I think yes. So I'll spend some time on this slide, right? So I'll first focus on the bubble plot that side. So on the x-axis, you see years, right? So 2020, 21, 22, 23. On the y-axis, you see a metric. You can think of this as an accuracy metric. How good is the translation? That's what is being measured here, right? And now any language that each bubble here corresponds to one of the 22 languages. The larger the bubble, the larger is the speaker base for that language, right? So we want the bigger bubbles to be at the top because that means you're serving a larger population more accurately, right? And any bubble that you see below the 0 mark is a language which is not served by that model, right? So that language was not even supported by that model. Okay, so I hope the sort of notation nomenclature is clear. Okay, so now in 2021, Meta had a model which supported 100 languages. As you can see, many of the Indian languages were not supported. They are all below the 0 axis, 0 mark. And the languages which were supported, you can see many were, just in, right? They were not really doing great. They are around the 20 mark or 10 to 20 mark, which is not at all good. For you to have reference, somewhere between 50 to 60 is the point at which machine translation systems become really usable. What do I mean by that? That is the point at which if you generate a translation using a machine translation system and then ask a human to edit it, the human would be happy to do it. Anything below 40, the human will say, please delete this, I'll translate it from scratch, right? Because there's too much headache for me to correct what you have given me, right? So that 50% is that reference mark for you to have, right? And you can see that many languages were below that. In 2021, which was our first work when we started on IndicTrans, so we were able to push the sort of boundary for the languages which are already well supported, but we are not able to do much about the languages which are not supported. Those still remain unsupported in our models. In 2022, Meta came up with this famous No Language Left Behind LNLB model, which supported 44,000 directions, right? A very huge number. And again, many Indian languages were left behind, but many were included, and the needle was also pushed a bit more, right? Then in 2023, we released the first model which supported all the 22 languages, whether open or commercial model. And we are able to push most of the languages up, and no language was left behind, right? And as we speak, we are training our next generation of models in 2024, and we hope to release something in a couple of months. And we're hoping that these bubbles would move up and we would have more languages, or almost all the languages, in the 50 to 60 range, which is the really usable range that I was talking about, right? So that's what that plot is showing. Also at AF Abad, it's very important for us that the work that we do, while it stays academically relevant, because we are an academic group at the end of the day. We have PhD students who have to publish papers and so on. So it is very important to be academically relevant and get published. But it's also relevant, it's also very important for us that it really competes with the best, right? I mean, it's not a model which is, okay, good, you have done something, but there are models by deep tech or commercial models which are better than yours, right? So we always benchmark ourselves against commercial models. And what you see here is Azure, Google, Meta, and our model. These numbers are averaged across 22 languages and multiple benchmarks. So this is an average number. And on average, my objective opinion, detaching myself from this work, is that we are at par or comparable to whatever models exist out there in the commercial world. But these are, of course, average numbers over 22 languages, multiple benchmarks. So it's possible there's some language, some benchmark where we are a bit lower, right? That's quite possible if you zoom in into that entire axis. But on average, right, objectively speaking, now we have models in the open source which can really compete with whatever are the best models out there, right, using the recipe that we have. And we are really hoping that with what we do next, we should be able to make more dent into what you see here, right, and really push the numbers up further. Okay. Now, fine, this is done for machine translation, but the question is that, is this recipe reusable? Because there's no dearth of problems that we have to solve. Right? Machine translation is one of the important language technologies that we focus on, but there's other speech recognition, optical character recognition, transcription, and so many others, right? So does it work for other cases also? And the answer, fortunately, is yes. We have then the same sort of jugaad for speech recognition also, where what we did is, thankfully, the government of India, the news on All India Radio, broadcasts 3 news segments every day of 10 minutes each in 40 plus languages, right? And because these are news broadcasts, it's not just the speaker speaking, but there's also a very nice transcript attached to it, because the speaker is actually reading from a transcript, right? Because it has to be precise and accurate and so on. So that's exactly the kind of data we need for speech recognition, audio and the parallel transcript, right? And this is available in abundance because every day 30 minutes of audio is coming in over several years, right? And there was this window of period when it was all up on the AI All India Radio website, and our smart students immediately sort of capitulated on that small window and crawled all the data from there. And then we are left with this problem that you have long audios of 10 minutes and like a 5-page transcript. But that's not what I want. I want like 10-second audios and the corresponding alignment there. But there's a long history of work in speech community where this long audio alignment is, I wouldn't say considered to be a solved problem, but a lot of progress was made on that. So we could just use those algorithms and align at a granular level, right? So we could get 10-second, 20-second audios aligned to the corresponding transcripts in the PDF, right? And volume was important here because anything that we were not confident of, we just threw it from the data, right? If I cannot get a confident transcript for this 20-second segment, I won't bother. I'll just remove it from the data because I have a large volume of data, right? So that way we are able to automatically get 6,700 hours. But as I said, mine data always has challenges, right? I mean, though the algorithms perform well, I'm sure there are many cases where it's not accurate and so on. Not just that, because this is news reading, it's not that every day a new person is coming and reading the news bulletin, right? I mean, at max, they might have 5 to 10 news readers for Hindi, right? Maybe one each for evening, morning, afternoon, and then maybe a backup for each of them or 2 backups for each of them, right? So that's all that might be. The speaker diversity is very small here, right? And that is very important, but the vocabulary coverage is good because you have news about politics, you have news about sports, science, everything, right? So all of that comes in, right? So it has some advantages, many disadvantages also, but it's free, so why not grab it, right? Let's start that to bootstrap at least the models that we have. And around that time, it was also very popular to sort of use pre-training, which is still popular, but in my opinion, not as popular and impactful in speech recognition now as compared to in the text world and even the speech synthesis world, right? But yeah, this is just a statement which needs more delving into, but that's what our current sort of assessment is. But we also are sort of collecting a lot of unlabeled audio, which can be used for semi-supervised training of these models, and hopefully the low resource languages where we'll have lesser amount of data will benefit from this unsupervised pre-training, right? And in parallel, we have efforts where we are collecting data from the field. If time permits, I will talk a bit more about that, where we have people going on the ground and collecting data. This is one of the largest data collection activities along with Project Vani at IIC, which is trying to collect data from the field, right? And this is known as spontaneous speech, which is very hard to collect because you want all the natural speech artifacts. When you and I talk, we have a lot of ahs, we cut sentences midway, jump from one place to another and so on, right? And that really needs to be captured, as opposed to news, which is very clean, right? Because you hardly see a newsreader make a mistake or an unnecessary pause while reading the news, right? So that needs to be captured. And we have been training all the different architectures, Whisper, Wave-to-Wave, Conformer. Just 3-4 days back, we have released our latest model, which is again the first model to support all the 22 scheduled languages of India. It's a conformer-based model. The demo is up on our website. Please try it. And there's also a place to submit feedback. So please do that. We would like to see how the models are doing. And as we speak, we are already training the next generation of models. The current model is 130 million. But we feel that we could train a bigger model, a 600 million or a 1 billion parameter model, and then distill it into a smaller model. So that's the current activity. And generally what we have seen, right, I mean, 3 years looking back, is that we see the snowball effect where a lot of things that we were doing have slowly started snowballing, and now there's a bit of momentum where we will perhaps be able to accelerate much quicker than whatever we have been doing for the past 2.5, 3 years, and maybe do much more in the next 6 to 9 months, right? I'm hopeful about that, and I hope I come back next year and talk about that or something like that. Yeah. Okay. So yeah, so now I'm going to zoom in a bit, right? So the recipe had 3 components. One was the heavy on engineering mining. The second piece was the manual data collection, and the third was on compute and so on, right? So I'll talk a bit more. I'll skip a few slides, but I'll talk a bit more about the manual data collection effort that we have. So I was saying this is one of the largest data collection efforts that I know of, not just in India, but anywhere in the world. I don't know of any open source effort where people are going to the field, collecting data, transcribing it, and then releasing it in the open source, right? Just to give you a sense of scale, there are a total of 700 odd districts in India. We are going to 500 of those districts, spread across the country, of course. And every district, we mobilize 150 participants, and then we sort of have a discussion with them and sort of collect their voice samples, and then backend come and transcribe it, right? So that's what the process is. Now, how do you do this? How do you sort of do this at scale for covering all the 22 languages that you really care about, right? And because how do I, sitting in Chennai, reach Assam? How do I collect data from a district in the Bodo part of a Bodo speaking part of Assam, or the Santali speaking part of rural West Bengal, right? Or the Santali speaking part of Jharkhand? I mean, it looks quite spread out and diverse, right? So how do we do that? So we sort of will spend a lot of time in building this pan-India team. And given the nature of our languages, nature of the population that speaks those languages, the diversity in that, no single solution, as you can imagine, works for all the 22 languages, right? So if you're looking at what, I mean, just for the want of a better word, if I look at mainstream languages, which are probably more speaker based and so on, which are the peninsular languages starting from Gujarat, then Maharashtra, Goa, Karnataka, Kerala, Tamil Nadu, and going up till West Bengal. So there are these 12 languages which have fairly good city centers, right? So you have popular cities in this, and you could think of vendors having headquarters at these places, right? Bangalore, Chennai, maybe Cochin and other places, right? So you could get vendors, and probably for these languages that would work. But how do I find a company or a vendor which has a headquarter in Manipur or Assam? These are not traditionally places which have a lot of this kind of activity going on. It's not that a lot of data has been collected in the past and so on. So what kind of solution do we use there? So there we've sort of partnered with local NGOs. We found people from the social sector who have grassroots level connections, right? And we partnered with them. We sort of took their help in mobilizing these 150 people. Not just that, when you go to a place, and I should talk about that, right? So that's the building a team part. So I'll just not talk about the second part right now. So we sort of built this team where in many places we had vendors, in most places we had NGO partners, and some places we had university partners. So in Kashmir we partnered with Kashmir University, where it's a very known name there, very trusted name there, and they also have a very good linguistics department which does these field surveys and so on. So they have experience in doing that. So with them, with the help of them, we could reach to many different parts of Kashmir and actually mobilize participants there and collect data and so on. Right? So that's building the team part. The second is design for scale, right? So this is an effort which probably will yield data which should last at least for a decade, right? I mean, it should be, I would be very disappointed like if 5 years down the line I hear that, oh, no one is using this data now because better data sets have come out also. I'm really hoping that it stays much longer than that. Of course, newer data sets will come in, but this should still remain a part. And if you're doing that, if you want to do it at scale, you have to standardize the processes, right? You have to make sure that the same process for data collection is being used in Manipur, as in Goa, as in Tamil Nadu, as in Punjab, and so on, right? So we designed tools and questionnaires, right, to make sure that the same process is followed everywhere. All of the data is centralized. So I've seen vendors who go and collect data, put them in Google Drives, and then sort of backend something happens and all of that. That doesn't work at this scale, right? You really need to have a centralized tool where everything is directly going to a backend server at one shot, and all of the data is coming to a centralized repository. So we again invested in building a lot of these infrastructure in-house, right? Then mobilize for diversity. As I said, we need to really partner with local people. We had a lot of funny incidents where we got YouTube and Instagram influencers to actually make reels and then put it on their channels that, hey, someone is actually a very funny reel one of the Konkani guys made. Do you know that someone is willing to pay 1,000 rupees to you to speak Konkani? Because that's what we're paying the participants to sort of spend time. Can you believe that someone is going to do that? And yes, someone is doing that, so please go at this center and sort of contribute for your language and so on. And then of course he ditches the funny part and talks more about the serious part and so on. Right? So we got this natural organic participation also, where people were coming to help us and make sure that we get this 150 participants. It's not at all easy, unlike what I had initially assumed, because it's not just 150 random people, right? If that's the case, I'll just go to every IIT in each of these states, wait at the gate, all the students come out for chai, samosa, and I'll just say, okay, I'll pay for this and you give me data, right? But that doesn't work because it's a very specific demographic, very specific age group, very specific educational background and so on, right? And we need much more diversity in age groups. We need much more diversity in educational backgrounds, in professions and so on, right? Because people would have different worldviews. I want someone to really talk about their pain points in farming in a rural place and so on, right? What is the challenge in getting seeds? What happens if you don't get water supply for 2 days and so on? And of course, students may not have the right exposure to talk about these things, right? So it's very important for having diversity, right? And the fourth part, right, which was again, very naively we assume that, okay, if you go and ask people to talk, they will talk, right? But no one talks, right? You say, I want to talk to you for 10 minutes, can you talk with me? Hi, hello, how are you? That's it, right? I mean, after that, what do they talk and how do you keep them engaged, right? So that becomes very difficult. So after we did our first pilot, we realized that, oh, nobody wants to talk to us, right? So we have to make them talk really. So then we went back and designed detailed questionnaires. So we picked up 60 topics of interest, ranging from drawing, painting, horse riding, hiking and so on, to politics, sports, everything that you can think of, all the important topics in India. And then we designed questionnaires around it. I'll take one example which you will relate to. So sports is a topic. We'll start with how did you start watching sports and what made you get engaged in it and so on. Invariably people would say cricket. So then the next follow-up question was, which is the last memorable match that you remember and why was it memorable for you, right? And as you can imagine now, different people, based on what their favorite player is or what is actually the last match they saw, will end up giving different answers, right? Someone may talk about Bumrah's 5-wicket haul, someone may talk about Virat Kohli's century, someone may talk about Yuvraj's 6 sixes and so on, right? So you naturally get diversity by framing these questions. So a lot of effort went into sort of iteratively creating these questions and ensuring that there is enough sort of engagement from the participants. One other thing that we realize is that if you go and ask people, tell me 2 topics of interest in India, what are the top 2 choices which come up? All correct answers actually. Sports, Bollywood, or whatever. Sports and entertainment is a top 2. Religion in certain contexts, yes. Politics very rarely, because people are afraid that if I start talking about politics, the kind of things that I'll say you will not be able to record, right? So, and that actually happened to us. We had to actually stop a participant midway because he just couldn't stop himself from swearing throughout, right? And then he got offended that we stopped him. He said that this is my language. Without this, my language does not have an effect, right? I mean, my language requires me to express this in this way. And you're stopping me, and then you're saying that you want to collect culturally relevant data. How are you doing that? Right? And then we had to explain to him that, no, boss, this is for government, and if someone sees this, then it looks bad and so on. We had to pacify him and then sort of start again the conversation, and then he honored the rules and did not sort of go beyond certain boundaries and so on, right? So a lot of very rich experiences, and I think some of you should talk to my students who have, I've gone with them to many of these places, but they have perhaps gone to more very, very interesting experiences. In Manipur, we had a case where one of the questions that we ask is tell any 5 dates, right? And the reason for that is that in many applications you say dates, right? So date of birth, if you want to fill a digital form, date of birth is something that you will be asked, or some date of passport and so on, right? So we wanted to capture different ways, and people say dates: 15 December, 15 December, December 15, 1981, 81, and so on. So that is one of the questions, and we asked one of the Manipuri participants to say that tell us 5 dates. And she started talking about the first date that she went on with her boyfriend and so on. And I'm like, no, this is not here asking. We're just asking you to tell us a date, right? And then people get into details that this was the date on which my child was born. It was a very important date for me. No, we don't want that. Just say the date and that's all, right? So a lot of interesting, very enriching experiences in understanding how people sort of react to this at different places. We've gone to places where there was a curfew and we are going there to collect data and so on. We didn't know that, otherwise we wouldn't have gone there and so on. But all of that was there and sort of involved in maximizing this engagement on the ground, right? Now the last bit is that when you're doing this at scale and trying to get data from everywhere, of course quality has to become a problem at some point, right? Because we go for the initial pilots, we make sure that people, that our coordinators in Assam get trained. But at some point, of course, we'll come back, right? And then the work that we do in the pilot is perhaps 2% of the total goal, or less than 2% of the total goal. So the remaining 98% still has to be executed by the team offline. And we have to make sure that the quality sort of doesn't sort of drop after a while, because there are incentives here to sort of skip on quality, right? I just want to finish 100 participants, that's the quota that I have. So I'll do it quickly and sort of not bother about quality, right? So we have quality control team backend at our lab. For each of the languages, we have 3 to 5 people who listen to every single audio that gets collected on the ground and sort of rate it along 23 error categories, right? So there was a lot of background noise, which is fine because we want noisy data, because speech recognition systems are going to work in noisy environments, but we just want to know that there was noise, right? Then there are cases where people are just talking off topic, right? I mean, the question was about sports and you start ranting about something else. As I said, offensive content is one more thing that we control for. And sometimes people just start repeating because we have told them that aapko 20 minutes ka data dena hai. So they start speaking on a topic and I went there and this happened, then I went there and this happened, then I went there and this happened, and just the same thing being repeated just to fill in the seconds and so on, right? So we try to cut off all of such data which is repetitive and off topic and so on. So every sample is sort of listened to, and our rejection rates often, like when we start off, are 50%, right? 50% of the data that comes in gets rejected, and we aim to get it down to 20%. And for some languages, we just are not able to do it, right? So it's still 30%, 40%, and so on. But at least whatever falls in the bucket is good enough, right? So that's what the aim is. I'm sure still some noisy data slips in, but at least we are putting in the processes to ensure that, right? So that's like zooming into one of the parts, which is about the manual data collection, just to give you a sort of sense of why I said at the beginning that this is expensive and you cannot do this at million scale. Maybe at 1,000 scale you can do it. 1,000 hours of data per language is what we're trying to correct, right? So now whatever I had to say, I have sort of said on these slides. I'll go to the next one. Now the question that was is this recipe reusable, right? So we have already done this for translation, speech recognition, large amount of noisy data, small amount of very high quality data, and then training multilingual models. Now this year our plan is to do the same for speech synthesis. I think we'll be delayed by 3 months, so maybe not December 24, but maybe March 2025. We'll try to put out speech synthesis systems which are natural speech, right? So when we started off in 21, even for English, natural speech was not out there. I mean, like the way you see with what ChatGPT is able to do today, or even the natural speech model from Microsoft, or some of the other models which are out there, they were still like high quality audio. You can feel it's studio quality, but not really very natural, right? But now for English, in the past 3 years, it has taken like a giant leap, right? I mean, many models that I see are now producing very, very natural sounding speech. They work with prompts. That means you give me a 3 second, 5 second angry audio of the speaker of interest, and it's able to then generate like a new sentence, unseen sentence in angry expression for that speaker, right? So it's really evolved a lot, and we want to sort of close that gap in the next 6 months for Indian languages, again using the similar recipe that I spoke about for other languages. Okay, how are we doing on time? 10 minutes, okay. Yeah. So now, while all this is happening, right, as I said, one of the important things for us is that do work which is academically relevant, compete with the best, but also make sure there is impact on the ground. So a lot of the stuff that we do, thanks to our partnerships with our generous donors, which is Bhashini as well as Nilikani Philanthropies, one being the government, the other being like a foundation slash NGO, we get to sort of deploy some of the things that we do on the ground, right? So with the help of AkeStep, we have a project going on with Tamil Nadu government, and we generally are just the people in the back. We don't do a lot of front facing. AkeStep Foundation takes care of that. So what they're trying to do is improve the oral reading fluency of children in schools, right? And I'm not sure whether you're aware of it, but there are several studies which show that during the COVID period, because of online schooling and other reasons, the reading fluency has further gone down. It was already not very remarkable for many Indian kids, but has gone down further, right? And now there are efforts to improve it. And now we have a very simple solution that AkeStep Foundation has developed, which is the student. All of these government schools have like a computer, like the dabba kind of a computer which is there. It's connected to the net, fairly reliably works and so on. Now the student just logs into a browser and he sees a Tamil sentence, right? Or maybe starting with the Tamil word itself. And they read, the student is wearing a mic and reads out the word. Okay. When the student reads out, in the backend, our speech recognition model runs and tries to recognize what the what the child has spoken, right? And suppose the word was apple and the child spoke apple, right? Then it will mark it as, oh, there was a pronunciation error here. This does not look like the word on the screen. And once you collect a lot of such data, you can imagine like a dashboard of data analysis on top of this, which shows that this student struggles between p and b, or this student struggles between bh and m. So let us show them more words over a period of time. And of course, for every word, there's also the gold standard pronunciation available, right? What you see in Wikipedia and other places, right? So that sort of is being used at scale in across 50,000 schools, I think, in the country right now, where they're trying to measure this, right? Now, of course, I'm increasingly realizing in the education field, it takes a lot of time for things to then start producing impact and results, right? I mean, right now it's all data collection, trying to understand what problems the children have. But for this to really get to a level that we are able to show that in 3 years, the reading fluency improved from X to Y, I think we are not there yet, right? But we are hopeful that we'll get there. So that's one on-ground application. And we also work with NPCI through Bhashini, where the idea is that voice payments need to be more inclusive. So in India, there are still 330 million users who are on feature phones, right? So they can't do an app-based transaction as you and I do regularly on GPay or other places. But they are all having bank accounts now thanks to the Jan Dhan scheme, right? So now if someone wants to transfer money through an IVRS call, then I was told that it takes 51 key strokes to do that, right? Like a 16-digit number for the account, your account number, the other person's account number, then some PIN, then some confirmation and all that, right? Now, the task that was given is that, can we just do this through a voice call? You're calling from your registered number, so some sort of authentication is already done through that, and you can enter an MPIN, a 4-digit number. But after that, you just say that transfer X rupees from my account to this account, right? And you can either speak the account numbers or even just say a name from your contact list, like an already registered name from your contact list, and the transaction goes through, right? So last year, NPCI demonstrated this in GFF in September for Hindi, and now they are on a mission along with Bhashini to sort of enable this for all the 22 languages. And the models which get used underlying, although we don't build the solutioning layer on top of it and all that, we don't get into that. But the underlying ASR model is something that we have developed, which goes into their solution. And they, of course, further improve the model, right? Because our base models may be 80% accurate for their use case. But now with them, we have worked out a recipe where after this, they do a delta work of 15 days or 1 month, which helps them get this 80% to 92% understand. Please repeat what you have to say. It's a pain, but it's okay. 8% is not bad, right? So that's how it is being used. The other use case we have is the Supreme Court of India, where since its inception, the Supreme Court has released 35,000 reportable judgments, and the current Honorable CGI has set up this mission that all of these judgments should be available in as many regional languages as possible, starting with Hindi, definitely top 12, and if possible, all 22, right? So that's the goal. And using the translation model that we have, the goal here is not replacing a human. It's a very sensitive document, right? You cannot afford mistakes here. It will have solid downstream repercussions, as you can. To hire these retired judges who are domain experts and then are willing to do this and sort of get familiarized with the tool and all that. For us, it's easy to just provide the technology, but someone has to orchestrate the whole thing across a wide network of judges and so on, right? So these are some of the things where we deploy our solutions to make sure that it's usable on the ground, right? So I am okay to take a stop here, and I can go on also, but I'm okay to take a stop here. Okay, yeah. So now going forward, right? Yeah. So what next, right? So I'll just spend like 5 more minutes on this. And disclaimer, I always give this, is that I'm going to simplify things for English, outrageously simplify them for English, and outrageously exaggerate the situation for Indian languages, right? So please bear with that. So now if you have a chat.openai.com, right, all of you are using this ChatGPT model, then what did it take to build it? Again, I'm going to sort of really simplify it. Is that some pajama, right? I was slim pajama, red pajama, all these documents were already existing, very large corpora, X trillion tokens served on a platter almost, right? Because Common Crawl has already done the crawling. You have to take that, right? And then you have large amount of compute to train the model, and you're ready with chat.openai.com. Of course, simplifying, there's a lot more which goes into this, but at least the data part is solved. Not just that, right? Once the model is released, all of us Indians who have perhaps no business sort of going and testing this model, we all go and test it, start typing in English happily on an English keyboard, and are happily using the model. And there are trillions of, not trillions, but tons of benchmarks already available on which this can be evaluated. So academic evaluation is also possible, and real-time user evaluation is also possible. All of us have contributed, right? We have happily evaluated and then said, hey, this is not good, can you please change it, and so on, right? So we have been doing that. And because we know how to type in English, right? And we know English and we know how to type in English, it's very convenient to type in English, right? So that's the English story, right? Now if we compare this to the Indian story, right? If I want to build like a chat.indicllm.org, what do we have to do? And our problems start like way below, right? And first of all, none of these X trillion tokens are available. The tools required for collecting such data at scale are also not available, right? So we have been investing in building these tools from scratch, tools for manual data collection, Shunya, Kadbat, and now Anudesh, which is something that we have released this week, which is for collecting data for LLM fine-tuning and so on, like prompt response pairs, preferences, and so on. And we are hoping to start an effort where we again start doing this at scale and sort of collect more culturally relevant data. That's again for fine-tuning and alignment and so on, right? But even before that, as I said, it's a known secret that all the web data has been taken in ChatGPT. A lot of content from YouTube has been taken. When I say web data, I'm mainly talking about HTML data, right? The text, machine readable data. There's a lot of PDF content which has also been taken, right? All of this is, I hope, open secret, which is like taking data from archive.org or scanning books at scale and just taking all the data from there, right? Where do we have PDF sort of readers for Indian languages, right? Because as I said, a lot of our earlier content, when we started digitization, all we meant is there's a paper, I'm going to scan it, make it an image and upload it. That's only half digitization, or maybe only 20% digitization. What we mean by digitization is actually making that machine readable, right? But that is not really done. You have all images uploaded. So you need to have PDF parsers, which are like the OCR, right? Layout detection plus parsing to be done to get all of this content out, right? So just as we have built Setu, we are now building on Anulek and Pratyaksh to sort of get all this PDF and YouTube content also going in. And then we'll get some sort of a Sangraha, which is equivalent to the Slim Pajama datasets, still much smaller scale. We're also now, we or many people are looking at generating synthetic data at scale so that this can be augmented and got this. So this is not served on a platter, right? We have to really work hard to get this data. When I say we, I mean we as a community, not necessarily for Bharat or me, right? So that needs to be done. Even after that, right, if you use this data to train a model and let's say put out a reasonable 30 billion model which hopefully performs well. Now let's see what happens when users come in, right? None of you are going to go and type and deal with that model. You're happy to type with ChatGPT because it allows you to type in English. If I ask you to evaluate these models in your regional languages, I'm sure most of you, I'm passing a judgment here, but I'm sure it's pretty right that none of you will be able to type in your regional language, right? If I ask you to type in Devanagari, you'll not be able to do that. You can write the Roman version of it. You can type GHAR if you want to say Ghar, but typing in Devanagari is not something that we formally learn anywhere, right? So either you would want a voice-based interface, so you need to work on speech recognition systems, or you would want a Romanized interface. That means you need to work on transliteration, right? So this needs to be built. These blocks do not even exist in the English figure that I have there, right? Then you're going to happily switch between English and article on Battle of Panipat written in 22 languages. I'm not going to have an, but I may have to also, there would be value in translating and passing it. Now similarly, once the LLM does its magic, the answer will have to be translated back and synthesized, because again we are not very good at reading in our languages, right? So I would want someone to nicely speak out the answer to me so that I don't have to take the pain of reading it, right? So we need speech synthesis for a very long time, have our own sovereign